Right. Hello and good afternoon, everyone, and welcome to the fourth day of our Unlocking Innovation event for this month. And this one will be, as we know, is on developing whole systems for railways in the digital age. Today is going to be slightly different, as instead of just being purely about lectures, we're going to be looking at simulations and modelling. And some of the people today, where possible, are going to do some demonstrations of their tools and how they work. So I'm really pleased to welcome everyone today. If I could ask everyone who's not speaking to make sure that their cameras and microphones are switched off. And also, what I've decided to do after yesterday, I think the best thing is, if anyone who's got any questions, if you can just pop them in the chat, I will let all the presenters have their spotlight, and then at the end of the day, we'll have a panel session and combined panel and Q&A session, and we'll go through everyone's questions with all the speakers at that time, just to make sure everyone's got time to do their full presentation. And it could be a bit as well worth giving them a little bit more time today, because obviously some of them might be switching over to other programs and so forth. So today and the presentations we're going to have today come from a wide variety of the industry, including HS1, Fraser Nash Consultancy, the University of Birmingham, and the National College of Advanced Transport and Infrastructure. Each presentator is going to have 20 minutes, and if you could put any questions, like I say, to them, and then we'll bring them at the end. We'll finish off today's session with a full panel discussion as well, and looking at how we best utilise these tools as we go forward to develop systems. So, to start, let me introduce you to Peter Turrell, who's got. I should actually turn this off first, of course. Peter is from HS1, and he's going to be talking to. Unfortunately, his colleague Jay Newton can't be with us today, as Jay's just had an operation yesterday. Thankfully, it all went well, and we all wish him a speedy recovery, I'm sure. And so, Peter, is going to be talking to us about the digital twin that HS1 have been working on. So, Peter, if you like, I'll let you start straight away. Thank you very much.
Thank you, Colin. Yeah, good afternoon, everyone. Right, I'm just going to share my screen. Potentially a little bit, unfortunately, I'm actually doing a slide pack today because we don't actually have any simulations to show you. I'm just hoping that's going to load. Put a spinning wheel. It's not a good start, is it? Let's try again. Oh, aha. Has that come up from it? Can you see anything? Carl, can you see
it? It has, Peter. We can see it perfectly. Thank you.
Good. Right. So, yes, I'm going to. Let's close that window. Sorry, I'm just. Right. Is it full screen for you as well?
Yes, Pete. Yeah, we can see a full screen.
Brilliant.
Thank you.
Okay, so yeah, I'm going to talk to you today about HS1's development around digital twins. We've got two slightly different takes on this, which I'm going to take you through briefly today. But prior to that, I'm just going to give you a very quick overview of who we are as HS1, just in case there's anyone on the call who doesn't know. But some of you probably would have met Diane on Monday this week. So HS1, we have a 30-year concession to operate the high-speed railway down predominantly in Kent. It's 300 kilometres per hour at high speed, completed in 2007, goes from St Pancras down to the boundary of the Channel Tunnel, and we've got 4 stations. We're privately owned, and obviously our kind of core business is high-speed rail for domestic, international and international freight as well as passengers. We also have retail and some car parks, etc. as well, but predominantly we are a railway. So that's a very quick overview of who we are. And now to set the scene a little bit around our digital capability. So I joined HS1 just over 2 years ago, and I felt there was a need to try to set out our vision, our aspiration. So we created an infographic. We worked with our supply chain stakeholders to work up what we wanted to achieve, set a little bit of intent of where we wanted to take both our organisation and the supply chain. And this is just a kind of representation of what we created. We printed off some large copies, and in the pre-COVID world, that actually helped us communicate. That helped to communicate this because we put some of these posters up around offices, but obviously in the last year that's been a little bit less successful. But no, it's really just identifying some of the elements where we wanted to take the business in the coming years, and digital twin capability was one of those that we highlighted, and that's naturally where I'm going to talk to you today. So the first of the two that I'm going to explain a little bit about is more around Jay Newton's part of the organisation, and he's the head of stations engineering and operation at HS1, and this is where it's mostly focused around the customer and the interactions that we see from the customer. Now, taking that into a bit more detail, what we're trying to do is, as the title suggests, develop a platform to actually digitise and understand the movement of customers at scale. And so from that, as the 3 levels here in the depiction state, you've got the actual, I suppose, the monitoring capability, so measuring, understanding what's going on. That translates into actually the data that you host and hold about, in this case, the movement of people. We've got historical data as well, and you've got algorithms, how you actually manipulate that data, and then actually how do you use that data. So it's in real-time decision making or proactive planning, etc. So it's actually gathering information, data about the railway physical assets, in this case mostly customers, and then using that to purpose to make business decisions. So that's really what this system is about. That's all well and good, but what do we actually mean and what are we actually doing in that space? So what we've actually got is we're utilising essentially 2 forms of cameras. So the CCTV cameras that you'd historically have in a station type environment, but then also some modern specialist cameras, which enable us to create 3D imagery of the environment that they're taking, that the coverage is over. And then what you'll see here on the screen, the top right image is sorry, I've lost my train of thought there. The density, that's the word, the density of customers. And actually it's been very beneficial in the last 15 months during the COVID pandemic, because it actually enables us to understand social distancing and where there's pinch points in the station, and it enables us to actually modify and adapt how we're managing the station on a day-to-day basis to support social distancing, which has been fantastic. You then see in the bottom right-hand corner actually where it's more like a 3D image, and this is where we can trace the movement of customers. Now, I should note it's anonymized, so it's not specific against passengers, but it's tracking trends over time. And where that's really useful is we build up a data set of where people are moving to, where they're going from, so they get off a particular train on a certain platform, what route do they take through the station. And by building up the data over weeks and months, and then kind of overlaying that with incidents or events that happen in the station, we can begin to see how customers interact to circumstances around them. And this can help us not only with understanding if there's kind of maybe a lift or an escalator that gets out of service, and then we can see how passengers adapt or respond to that, or if there's large number of passengers coming through Eurostar or Southeastern. So if you get larger passenger numbers, you can begin to see how they interact both with each other and the physical environment around them. And where this can then really help is not only in the day-to-day live operation, but then actually also about some of our longer-term planning. So here I've kind of depicted, we can do scenario planning. We can optimise the planning decisions we make, whether that is around signage or whether actually we believe we need to adapt the actual physical assets, or whether we need more lifts or more escalators potentially in future. And so we have a large coverage of the cameras over St Pancras station in this instance. and it really helps us to understand customer movement. We can also begin to see, bottom right in this diagram here, how customers are using the retail space. So actually we can understand the numbers of people looking into the shop fronts, so we can begin to see that actually what displays work well, so we can feed that back to the retail unit, so they can maybe adapt and modify their offering to get support for customers. If we put pop-ups or the Christmas tree into the station, how do people move around that? Do we need to put different signage in? So really what I'm trying to convey here is, by virtue of this representation in the digital space of understanding the physical environment of the station and how the people move and interact with that, it will make us enable us to optimize the whole experience for the customer, and so we can put the customer at the heart of our future planning decisions that we make and take. And so I've already alluded to the fact that part of understanding customer behaviour is understanding how they interact with maybe the physical assets, so a lift or escalator, and that takes me on to the next project that we're doing, which is one which is more asset centric. And so if I move on to, sorry, I'm pressing the wrong button here. The second project we're doing, which is our 5G integrated railway augmented reality digital twin. It's a bit of a mouthful, but this is where it's far more linked to the actual understanding of physical assets. Again, like the first project, this is funded by Innovate UK. We've got a consortium of companies involved, so Pauly, Network Rail High Speed, Athernet UK, and the Advanced Manufacturing Research Centre based out of the University of Sheffield. And what this project is looking to do is bring together existing technology, but purpose them in a slightly different way and actually integrate them together. So we've got remote condition monitoring, a 5G private network, augmented reality, and the digital twin. And we're bringing those technologies together into one place to work for this project. So what we've actually got is one lift, one escalator, and a set of HPSS points which are just outside in the throat of St Pancras. And we're fitting condition monitoring equipment to those assets. We then can transpose or translate that data and performance information across the 5G network back to an Azure cloud to host the data and to store the data. We can then share that data how we need to, and that can be shared with maintainers, operators, people working remotely. And so what we're trying to do is integrate the flow of data and the people element and the physical element together. And as I've noted here in the use cases, or the main use cases, they're not the only ones. If you've got a maintenance operator out on site and they want to actually communicate with somebody in the office, then over the 5G network, they'll be able to share large volumes of data if necessary, very quickly and efficiently. We'll be able to get real-time monitoring of the physical assets via the 5G network as well. And then there'll be benefits from training and competency. And I'll show you a couple of images on the next slide of how that could work. So here's an image down at Camley Street Maintenance Depot, which was taken a few weeks ago. And it's one of the Network Rail High Speed maintenance crew with the HoloLens headset on. And really, this is where I imagine an individual working either out in the field or potentially more in a training environment in the depot where you've got training facilities. And with the headset on, you can either, with the digitization of maintenance procedures or maintenance information, you can actually have, through augmented reality, you can build a relationship and connectivity of that human interface to better I suppose, better for kind of a higher quality interaction with what would be the physical assets. So you could learn to take the gearbox of a set of points apart, for example. You could go through all the processes and procedures and make sure you know how you're doing it. You could be tested on it, and so you've got a higher quality training aid. But that could also work when you're out in the field. Perhaps you're a little bit unsure, or you want to just check some information about maintenance activities. You could put the headset on, or you could use a PC with the same information on, but you could stream it over the 5G network, and then you could bring up data and information that you need. And so it's thinking about how we adapt and evolve the capability and competencies of staff members. So that hopefully, the imagery here, it's still in design, so I'm not able to give you a real-time example today because we're still in the design phase of the project, but it's hopefully given you a flavour of how there could be that interaction through augmented reality and 3D modelling. I've also got on the next slide an image of Diane, who you may have seen earlier in the week. This is just in an office environment, but it could be very same for being in a control room, and you could begin to interact with the understanding of how assets are performing. So if there's a failure of a particular asset, or if you imagine this expanded across a larger asset group than just the 3 that we're doing for this trial. But then, yeah, it's really taken to another level the capability to interact and understand what's happening out on the railway with our physical assets. And I think that's where this kind of digital twin capability and technology can really aid businesses and probably help individuals who may initially want to kind of know where problems or issues are. It will highlight it very quickly, and you'll have access to it very swiftly. So that's hopefully, I'm looking at the time, I've nearly taken up 20 minutes already. Hopefully gives you a flavour for what we're doing at HS1. As I say, we've got the 2 projects, but we aim for them to be complementary, and in time we look to integrate the capabilities of these 2 projects, and there'll be other facets of digital twins where it will evolve in future, but we see them as complementary, so we can support customers and the end user, but also better understand the physical assets as well as that. Also, the projects are hopefully supportive of all the companies involved, and yeah, we feel like it's kind of quite new technology in terms of uses in the rail industry, and hopefully through sharing information like we're doing today, others learn from it as well, and we're on a learning journey as well. So I think that's my 20 minutes up. I hope that's been useful. I will stop sharing, and if you've got any questions, then please ask me in the panel later.
Thank you, Peter. That's much appreciated. Sorry, I meant to say when I introduced Peter that he's the head of asset management for HS1, and Jay, who couldn't be with us today, is head of stations management, or is it station engineering? Sorry, Peter. The Jay heads is. He's head of your station team, isn't he? Yeah.
Yes, that's. Yeah.
Thank you. Yeah, thank you, Peter. Thank you very much there. Very interesting, Peter. A lot of things to unpack. I had a couple of questions, but I must confess, as I got to the end, you answered them for me, so I'll have to pick over some new ones. Thank you. Moving on, I'd like to introduce. I think we've got the running order different. Sorry, I do apologise for everyone when I said the running order wrong. Nick Rodney, are you available by any chance? Sorry, Nick, I actually had you down second from the National College of Advanced Transport.
Oh, wow. Thanks for that.
Yeah, sorry, Nick. I thought I'd just put it the way I said it at the start. Yes, sorry. It's so Nick. If I could bring you up now. Nick is from the National College of Advanced Transport and Infrastructure. Nick's curriculum lead of digital rail technologies at the college, and prior to that worked in the railway industry for over 2 decades. So he's been in only slightly less than me. And he's just a joke. We're about the same, I think, Nick. And he's going to show us what tools are teaching the next generation of engineers to bring into the engineering industry, and what we need to be training, what digital skills we need to be teaching the next generation of our engineers and staff. So, Nick, if you'd like to I think you can just share your screen and it'll knock Peter off. Don't worry about Peter having to take his down, should just automatically come up. So, Nick, over to you. Thank you for joining us today. Really great to have the college joining us.
Thanks. Hopefully you can all see my presentation, yes?
I can see your slides, Nick. Thank you.
Yep. And is it full screen as well?
Absolutely perfect, Nick. Thank you.
Okay. What I'm going to do, so thanks everybody for having me, and I hope everybody else can hear me, and as well, just, you know, just in recognition, happy Eid Mubarak to those out there as well. So thanks for having me, like I said. What I'm going to do, because I'm going to be showing you some video footage as well of some of the tools that we use at the college. There's a bit of an issue with my computer. So what I'm going to do is just switch off my camera, and hopefully you should still be able to hear me. Okay. So I'm just going into this. So a quick introduction. As Carl said, my role is the curriculum lead for CCC, Signalling and Digital Technologies at NCATI. And yeah, I've been involved in the railway for over 20 years or 2 decades. And, you know, it might be longer, but I'm never going to admit to it. I think 20 years is about the optimum thing we should have. More specifically, so I've specialized in signalling systems, and I've worked on projects around the world for various different companies. About 3 years ago, so as NCATI, or then the National College for High Speed Rail, was started up, I then had the opportunity to transition from doing signalling projects into teaching and training. This is an exciting time at the moment, as the rail environment is changing due to the implementation of these new technologies. And ultimately, this will lead to a change in how we train others. So a quick overview for those of you that are not familiar with the National College of Advanced Transport and Infrastructure. It was formerly known as the National College for High Speed Rail before a name change, and the figures here shouldn't be of no surprise. Set up to address the skills shortages of existing and future infrastructure projects. We have 2 campuses in Birmingham and Doncaster. Both sites are equipped with workshops and trackside environments, and we cater for a range of services, including apprenticeships, full-time courses, and degree-level CPD. College was developed with input from industry stakeholders, and recently we became part of the University of Birmingham family, and that should hopefully open up more opportunities for the college and its learners. Right, so what I'm going to try and cover in this 20 minutes is just some thoughts on our philosophy on teaching and training. It's not the total, but just to give you a bit of an idea. Some of the tools we use to train learners on, and some of the challenges we face in developing these tools. A bit of a disclaimer, I apologise in advance for my East End accent if it comes out too much. So if there's anything that's not clear, please comment in the chat, and I'm sure multilingual Carl will be able to clarify. Now, we're all aware of the new technologies, digital technologies and processes being developed and implemented across our industry. Some have been discussed during this Innovation Week and include such things as what you just heard recently, such as digital twins, BIM, building information modeling, IoT, Internet of Things, and cloud technologies. It should be obvious to all that part of the planning for implementation of these technologies should also consider the training requirements of its users, especially as most of us on this call will be retired when future control period work and other projects come to fruition. And we all know that there is a chronic shortage in the workforce of those with relevant digital skills. Government reports have also identified that 72% of large companies and 49% of small medium enterprises are suffering tech skills gaps. So this has resulted in a government push for digital literacy, future skills required for the workplace, and the introduction of lifelong learning. Now, usually we think about digital literacy as about, doing things like doing online banking or sending emails. But for us in the real railway, we need to become familiar with these new technologies for the benefit of the industry. Lifelong learning, as you can see, there's the concept that we can decouple traditional learning frameworks post-college or university, and also learn to take ownership of our own education. This week, we just had the government announcement about the Skills and Post-16 Education Bill, a lifetime skills guarantee to enable flexible access to high quality education and training throughout people's lives. I'd also like to introduce the concept of experiential learning, or learning by doing, which we have developed in the college via what we call project-based learning, first set up by Reza, who's now at the University of Birmingham. And the way I think about this, when I think about learning to drive, obviously I drive a car. So when I think about when I first learned to drive, the first lesson is not usually with a driving instructor. And I remember my mum teaching me when I was about 12 or 13 how to move the manual gear stick, and allowed me to shift gears while she drove. She would also send me out to start the car, practice engaging gears, and this taught me so much about the car that I only needed the driving instructor for a few days to ensure I didn't have none of my mum's bad habits. I think that experience is not unique to myself. Some would argue you cannot read a book on how to learn to drive. You need to experience it. And this is some of the same principle that we can use for the training of future engineers. Active participation, introduction, familiarity of technology can help develop those future skills. So gamification. Games are a great way of utilizing technology to deliver experiences to our learners. What I've got here is a simple game called Paper Trains. Some of you might or might not have heard about it. It allows the learner to consider the impact of track layouts, the placement of signals, and different rolling stock behavior. Software can be run on PCs or downloaded on an app on your phone. As the layouts vary in complexity, with only one control point, we must think about where we slot or fit our trains between other trains. This helps learners grasp concepts such as layout risk, signalling, timetabling, and dynamic train movements leading towards traffic management. You can see I've crashed there. Okay, another game that we use is Train Station Simulator. Try and make sure it comes on. This game is essentially about developing a profitable station. It doesn't just look at running off trains though, but the interfaces between the station and other modes of transport, people, and facilities. The game helps us to understand the complexities with station operations, including staffing and security arrangements, maintenance and emergency situations. We must consider other transport timetables to get the optimum throughput and flow of passengers without overcrowding the station. So we're doing a bus timetable here. And we must also define timetables for our trains to increase our revenue. But this is limited to the number of available platforms you have. So you have to reinvest the money that you're earning back into the station by way of station upgrades. The game also uses artificial intelligence to provide feedback to the learner, how users feel about the station environment, and we must consider facilities such as bathrooms, ticketing, customer information systems, and the obligatory station bar. We also use augmented and virtual reality to immerse the learners into the railway environment without the risks of being on site or interfering with live operations. The Old Oak Common Station Digital Twin, which is developed for HS2 via Paulie was mentioned in the HS1 lecture before, is very useful to our learners in familiarising with station systems. Within this digital twin, though, there are also operational scenarios that can be run within the environment for the learners to get a grasp of all station management principles. Approximately, we've had this model now in the college pretty much for the best part of 2 years, and I know during COVID, especially, obviously this wasn't in use because, you know, we had to be careful of safe distancing and learners reusing the holographic headsets. But approximately 200 learners have been introduced to this model without any prior experience of the technology. One of the things, or a couple of things we found was as well, is that the AR VR experience is obviously not the same for everyone. And in fact, we found users of assistive technology, so maybe, you know, people might say special needs users, were able to adapt easier to using the AR digital twin than others. A lot of people that don't use assistive technology complain sometimes about, you know, they could only utilize the goggles maybe for 5 minutes at a time, etc., etc. We also work with several vendors who have made their software available under educational license and provide technical and teaching support, with experts attending the college to deliver teaching sessions. So there we've got Prover. Prover has given us access to their automated interlocking data development software. Hitachi as well has given us access to some of their design software. Autodesk, who do AutoCAD, and Bentley, who do MicroStation as well, give us educational licenses. You might also notice I've got on the slide there Amazon Web Services. Yes, we are utilizing a lot of Amazon Web Services materials to teach concepts such as IoT, data analytics, and cloud networking, all important stuff, the infrastructure of our digital technologies. We utilize Bentley 3D modeling software called Concept Station to give learners an insight into high-level railway conceptual design. I'm going to show a quick video highlighting some of the key benefits of the software. Hopefully, you'll be able to hear it. You know that you can hear this.
We can, thanks, Nick.
Great.
Take advantage of Open Rail Concept Station on your next rail project by planning and visualizing that concept quickly and easily. Here, as we begin a project using the built-in location tools in Open Rail Concept Station, we create the project, defining a project area. Then, using geocoordination services, we are able to query and download data such as imagery and terrain, which you see here. Upon the download of that imagery and that terrain, that data is compiled and creates the area, the project area, and a reality mesh, giving us full context of the existing conditions within our project area. Now, as we begin laying out our conceptual rail line, we lay out in the horizontal our rail line, taking into account design criteria such as railway classification, design speed, as well as typical section. As we lay that out across our reality mesh, you'll notice that the cuts and fills have been calculated and modeled automatically. The layout of the railway is modeled in 3 dimensions, so we can rotate the view up to see that model. In addition to the railway itself, structural elements such as bridges can be incorporated into our rail line very quickly. Those structural elements have interactive capabilities so that we can make modifications. Here you'll see we're adjusting the pier location along our bridge over an existing roadway. Also included are analysis tools, allowing us to analyze our conceptual railway in relation to other elements. Here we're checking the bridge clearance over the existing roadway, and you'll note if we need to make modifications, we simply modify the profile grade line of our rail infrastructure and make that modification quickly. Along with bridges, tunnels can be incorporated within our rail lines. Here we're going to place a tunnel along the section of railway through the side of the mountain, and you see we can do that quite quickly, quite easily. The modification to the design model happens instantaneously. Modifications to that tunnel are quick. Here we'll just drag back and change the ending location of the tunnel. The tunnel has been modeled in 3 dimensions. We can rotate the view up and take a look at it. Just as before with the bridge, modifications to specific parameters of that tunnel can be made quickly, such as the shape, the width, the size, and so forth. In addition to those structural elements, a full library of turnouts from around the world are included as well. Here we're placing a turnout as we develop a yard along our conceptual model. Rail connections can be made quickly simply by snapping those connections to the turnouts. You'll see that connection was made very quickly. Turnouts can be incorporated as well. Here we'll just fit a turnout quickly into that area, again, as we continue developing this yard area within our conceptual design. In addition to the elements you've seen so far, overhead line electrification infrastructure can be included as well. So here we're going to electrify the yard area. We have included portals along with cantilevers. You can see those now in the model, incorporated directly in our yard area. Modifications to those OLE infrastructure can be made directly as we reconnect lines. Here we're going to move a mast along the railway, again along the bridge, just make a relocation of it quickly and easily. Design standards are adhered to throughout this process. Here you'll see that cant is included within the rail model as we enter and exit the horizontal curve. You can see the transition taking place. The concept can be quantified and cost estimates included very quickly. Here you see the tabulation of estimated quantities along with estimated costs as well, so that you can summarize the expenses associated with your conceptual design. In addition to the design parameters and the layout parameters, a full set of visualization and animation tools are included in Open Rail Concept Station. Here we'll simply fly through our conceptual rail line, again, ultimately to allow you to fully convey your plan or your concept to a broad audience. So on your next rail project, plan faster, make better decisions using Open Rail Concept Station.
Okay, thanks for that. So just a quick thing on that as well. Our students, our learners there at the college are actively using things like Concept Station. We also have, there is an Autodesk version called InfraWorks as well. And yes, they are designing projects on the fly with some great results. So apart from the software donations, we do have hardware, kit and equipment as well at the college. So what we've got here, Siemens have donated their ETCS simulator, which we utilize to give learners an insight into the differences between line side and in-cab signaling. So you can see this, the driver's desk there. In addition, this rig comes with software that emulates route setting, the interlocking, the RBC, and other communication networks. This allows us to simulate failures on the system for learners to interrogate and resolve, so they get a better all-round learning experience. So it's not just about seeing a pretty picture on the screen, it's also about interrogating the system. Prior to COVID, we had regular open days where the local community can come and interact with these tools in a fun, engaging environment. And yes, on the right there, that is a 6-year-old boy becoming familiar with ETCS. And the lady on the left is using a driver cab view video simulator. The challenge on this is to meet the timetable and stop within 5 meters of the signal. She is challenged to meet the ATO controlled ghost train on the same route. So again, giving familiarity to people and everybody about these digital technologies. First Class Safety and Control Limited have recently installed this depot control system and an on-track derailleur. And this gives learners an insight into access control and safety within a depot environment. I don't know if you saw from my first screen, my background. In the college, we do have a workshop with a train in it. We do have tracks, and those tracks extend outside as well. So it's a perfect place to simulate the workings of a depot. And again, so one of our plans is, or our aim, I've shown you these different systems. Our aim is to link all of these systems together to our trackside locations that we've got outside the college and equipment, so our learners can experience the interactions of these systems throughout the whole environment. Now, there are obviously challenges, so development costs. To create tools such as digital twins or games can become expensive. And also to train the trainers to utilize these tools to teach others takes time and consideration into how this can be incorporated into a curriculum. Individual needs as well. Not all learners are the same. One size does not fit all. We need to consider users' individual needs and have realistic expectations on what can be achieved with these tools. Also as well, we need these tools to be a bit multi-purpose, like the ETCS simulator I showed. From two purposes, as development costs can be large, we need to ensure these tools serve multiple purposes to create value for money. And on the other hand, multiple activities or scenarios within a training tool increases learner engagement. So just like the young kid who I was who learnt to drive, giving our existing and next generation of engineers the space to experience these new technologies and processes will stimulate the interest in the skills needed for our future railway. And I foresee the college playing a big part in that once we're over this pandemic. Okay. So thanks very much, and get in contact if you'd like further information. That's my email address, or I'm on LinkedIn, or indeed to arrange a visit to the college once we can. And on that note, I'll hand back to you, Carl.
Thank you, Nick. Very interesting. I think you were a bit more than generous saying that my accent was more easy to understand than your good self, mate, seeing as I'm a smoggy. I also have never been accused of being bilingual, but my wife is trilingual, actually, so I wouldn't, but thank you very much. I think we'll hand on there. Can we hand over to David O'Neill, who's joining us from Fraser Nash? David, if you'd like to come up. Now, he's not sent me any details on him, but seeing as we worked together for 3 years, I'll give a stab myself. Dave's one of the consultants at Fraser Nash, and he's been with them for about 3 years. Prior to that, he was with South Western Railway, where he was one of their maintenance managers, and he's one of the a very fine engineer who I've had the pleasure of working with on numerous projects. So, David, I'll let you take it away, mate.
Thank you very much, Carl. Yeah, sorry, I was going to demonstrate our depot modelling tool, but the time constraints have caused an 11th hour change to a presentation of our depot modelling tool, but I still intend to present the depot modelling tool all the same. So what am I going to talk to you about today? Well, I'm going to introduce you to our depot modelling capability, and in doing so, introduce you to the concept that we discussed within Fraser Nash around static capacity versus dynamic capacity of depots, how we take all the factors of a depot into account, how we use the depot modelling tool to solve real depot challenges, the benefits and added value of depot modelling, and talk to you a little bit about what else we can look at besides the capacity of the depot. And it says questions there, but I believe Carl is going to open the floor up for questions on a panel discussion after the presentations. So what is depot modelling? Well, historically, when we've looked at designing or increasing the facility capability of depots, we've based this on experience and the functional requirements of the depot, and for all the right reasons. But as we are moving into a more technologically advanced world, and as we have these technologies at our disposal, we should be looking at ways in which they can influence the decisions we make on the facilities we have on depots and how we go about designing depots. And this enables us to use systems thinking, to consider depots as a system of systems, to exploit simulation-based modelling, and to consider depots as a dynamic environment. So what do I mean by dynamic environment and dynamic capacity. Well, I'd like to use a short analogy. Consider a glass full of water on a table, and with that glass full of water, that glass is at its static capacity. It's not moving, the water is being contained by the glass. However, if I was to start moving or swilling that glass around, the water will spill out of the top of the glass. And eventually, if I continued that motion at a steady pace, the amount of water will spill out to a point where it will contain what is left within the glass. And if I was to stop swilling that glass around, the amount of water left in the glass would be the dynamic capacity, if you like, of that glass, considering the amount of agitation I've caused to the glass. And this is the same as the way we look at depots. We can look at a depot as a place where we park trains, a place that we maintain trains and carry out other activities. And we can count the number of spaces that we can fit trains into, and we can call that our static capacity. But when we consider that on these depots, we need to maintain these trains, we need to clean trains, we need to carry out other activities. We therefore need to move the trains around the depot. And this causes a change in the amount of space that we have on the depot. And so we call this the dynamic capacity of the depot. And there is often a delta between the static capacity and the dynamic capacity. And this is where simulation-based modeling comes in, because we can understand the dynamic capacity of a depot through looking at the depot as a dynamic system. So what factors do we take into account when we are looking at depot capacity? So typically when we're looking at the static capacity, which is always our starting point, we create a baseline and we call these inputs preliminaries. And for these inputs, we consider the total fleet size that's required on the depot, the maintenance activities that would be taking place on the depots. That includes the cleaning, the prepping, and the heavier maintenance activities like any wheel lathe activity, bogie drops, lift facilities that might exist. And then we also look at the road types and quantities. How many stabling roads have we got? How many shed roads have we got? How many roads with hop-ups have we got? How many CET plants we've got? That kind of thing. Out of that, we can estimate the total number of vehicles that a train depot can hold. However, to understand the dynamic capacity of a depot and to analyze this properly, we need to consider sort of a level of detail further than that. We need to know what specific stock types that are going to be on the depot. Each stock type has a different formation, different number of coaches, sometimes a different length of train, and they have different needs. The train timetable, the train depot, we often look at as a calibration point between the end of service on one day and the beginning of service on another day. But actually, the operations on a depot are dependent on the service operations during the day and the ability for those service operations to arrive onto the depot on time in the formations that are expected to enable the depot to carry out the work that it needs to do to maintain the scheduled maintenance regime that the depot has. And therefore, once it's completed that maintenance regime, it can then depart the trains into traffic the next day on time and start a reliable service all over again. So instead of looking at it from a reset point perspective, it's a continuation of dependencies that allow for us to provide a rail service on time and reliable for the passengers on a day-by-day basis. And in amongst all of that, we have the physical layout of the depot as well. I've discussed already that depots have different facilities, wheel lathes, bogie drops, maintenance sheds, cleaning sheds, but we have to consider the points directions, the working and operational constraints placed on the depot. So if there's a single line working on a depot, or speed restrictions to 3 miles an hour, which is often the case in carriage washes, we take that into consideration as well. And one of the most key elements of looking at this as a system is to consider the people as well. We look at people on a depot in two guises: those that have direct involvement with the train and those that don't. And we're really only interested in those that are hands on the train. But it's important for us to acknowledge that these people have different competencies, different availabilities, different shift patterns that are obviously commensurate with the requirements of depot activities. And we build that into the model as well. And that gives us an output, a series of outputs, sorry. The first of which, and is our key metric and success criteria, is the timetable adherence. This is the ability for the depot to allow trains onto it and depart the trains into service. And then we look at the depot movements analysis between those times, and we often see that one can directly affect the other. So if we don't manage one, then we don't mitigate the risk of not adhering to the next. Another output we can look to is staff utilization. Again, we can look at this in two ways. We can either use staff as a limiting factor on the tool and tell our clients whether the staff that they are already provisioned for is sufficient to provide the activities that are required, or we can look at staff as a non-limiting factor within the depot and tell the client you may need this many people to conduct so many activities on the depot, plus or minus the efficiency factor that they wish to add to that number. Road utilization we've found to be quite important for those that are looking to make modifications to depots on hypothetical scenarios and are looking to mitigate the risk of spending a lot of money to develop these modifications without having a full understanding of the value they're going to bring. So we can use the tool to understand how utilized that road is going to be, or those roads in that facility are going to be, and help them build a robust business case that is based on evidence as opposed to the experience and conversational elements of decision making. Out of all of this, we can also tell the client what their dynamic capacity is, and this is really dictated to us by the timetable adherence and the depot movements analysis. And we can then work with clients to understand how this can be improved, or try and help them to understand what else they might need to do elsewhere on their network to facilitate a reliable and resilient depot or hypothetical depot in a design scenario. So what do we do when we are solving real depot problems? And I've already touched on this, but we look at 4 key elements. We look at the depot, the physical layout, and we create a schematic of that depot in the tool. And this schematic allows us to look over the 24-hour period of modeling to understand where the pinch points might be, where the conflicts in movements might be, look at which roads on the depot through that simulation are highly utilized and which aren't. And it makes the user interface of the tool a lot easier to understand. We deliver this tool to quite a broad spectrum of people within the railway. Some of them come from an engineering background, some of them come from an operational background, but all of them can understand or find the relevance in the way that we present the information, because we use a very graphic method, and I'll show you that on the next slide. Of course, we've got to put trains into this, and in doing so, we look at specific fleet details, the size of the fleet that's going to be maintained or stored on the depot, the length of the coach and the number of coaches in that fleet, the speeds around the depot, often dictated by the standards and operational procedures of the depot, the time at which it takes to uncouple and couple a train with each other. We know that this varies between the different coupling methods that are used, but when we're looking at modeling the aspects of the depot, such as head shunts or uncoupling and coupling to form up services, it's important for us to consider things down to that sort of 5 or 10 minutes that we might take to uncouple and couple, so that we can give an accurate representation of what's going on in the yard between the key maintenance and other activities. People I mentioned, we can put an unlimited number of people competencies within the tool. The key discriminator we use for understanding staff utilization is those that have who actually drive the trains around the depot and those that don't. And that we single that out because it enables us to be able to look at the activities again between these functional systems within a depot. And then on the all-important timetable, we provide in a simple format. We upload a CSV Excel file into the system, and that gives us a baseline timetable to work to, for which we can use the comparison of adherence to, and I'll show you that on the next slide. So when we come to analysing these real depot problems, this is really what we're presented with. And the top half of the screen shows you the very rudimentary schematics that we develop. And within this picture here, or this image here, we can see all the features of the schematic that we can use to orchestrate or articulate the problems, challenges, and benefits of what's going on that depot. So if you look at the facilities that create a line down the middle of the screen there, you'll see some of them are different shades of orange. And this is worked out on a kind of a heat map method. The darker the orange, the more utilized that facility is. You'll notice across the left-hand side of the screen, there are 4 darker strips. They represent actual trains. And if I was able to zoom in on those, it will tell us the unique train identification number, class number, whatever we choose to use of that train, so that we can see where on the timetable that train has been introduced to the depot, where it is in its cycle of activities through the depot, and really hone in on what impact changing that train's routine is going to have on the depot as a whole. And you'll notice that there's one of the lines there is set out in red, and this is a movement from one point of the depot to another point in the depot. And this can show us how the model is planning its movements around the depot based on the activities that it's required to perform and the timetable it's required to adhere to. So looking at a depot in a dynamic way, what are the benefits? Well, first of all, one of the greatest benefits to us as Fraser-Nash is that we believe that the depot modeling software is unique, and we can create it to a bespoke depot. So any train operator, depot operator, or any other stakeholder of a depot can approach us, and we can create a bespoke model for that depot. And the model uses as a system boundary the depot boundary, and so it's quite clearly defined what is considered within that depot. The model analyzes thousands of permutations of the depot activities and uses algorithms to output an optimized timetable adherence, maintenance adherence, and utilization figures. And as I've mentioned a few times already, we try and put this forward in a fairly user-friendly interface, and the simulation is quite quick to compute. It doesn't take days to run. We can run several thousand permutations in a matter of less than an hour, which is really handy. And we can use this as an enabling tool. It's a cost-effective way of planning maintenance. It's a cost-effective way of planning modifications to a depot, and it can help inform improved operational strategies. And I'll come to in a second some of the other ways which we've used it. It also enables our clients to create a realistic output without the high capital expenditure of modifying a depot. We all know that many of our depots in the UK are legacy of very, very old depots. Many of them are now in built up areas where before they were in fielded areas. Many of them have facilities and functions on them that they would never have dreamt of when they were built 100 years ago, and we're constrained by a lot of that as well. And we're looking to always try and enhance our depots and make them better for new trains and new working practices. But this comes with a significant amount of capital expenditure. So to be able to justify that capital expenditure for a fraction of the cost is a really beneficial tool to be able to use for our clients. And ultimately, it gives us a really detailed understanding of what that depot can do, what that dynamic capacity is, and how that depot can be used to its optimum performance. So as I said, a lot of this is around capacity, but it doesn't just stop at capacity. We've looked at projects involved at the risk mitigation of depot construction and upgrades, looked specifically at staffing levels on depots and helped our clients understand their requirements or ability to meet their staffing levels. We're seeing a lot of trains being introduced into the railway network at the moment, and there are many more to come. And with this significant investment, operators and depot management need to understand if their depots are able to cope with not only the fleet as a physical attribute to their depot, but also the maintenance activities that fleet has to undergo, the extra facilities that fleet might require, and therefore we can integrate that into the model to give them a better understanding of what they might need to do to that depot to facilitate that fleet. We could do depot movement simulations, right down to train movements, road utilization and staff utilization. And we can use this also in collaboration with the maintenance regime change and help us in a greater context to inform a more optimized maintenance regime for our clients. And lastly, and slightly more historically now, we are able to help transport operators with their franchise bids, and I say that as it's seemingly a more historical activity now. But when proposing the use of depots and new fleets and trying to build that proposal to take on that franchise, the depot modelling tool is useful to help them understand the case behind the use and where they can best place their fleets, where they can best use their maintenance and their resources. So that's our depot modelling capability. Thank you very much.
Thank you, David. Much appreciated. If we have a bit of time at the end, David, or if you do want to show the tool, we might have a bit of time near the end if you'd like to do a demonstration after we've had the question there. And thanks very much. Finish off our round of presenters for the day, though. We now have Professor Clive Roberts again from the University of Birmingham, who we all know, and those who I think he needs very little introduction to most of you, but as you know, is the Director of Rail Research at the university and also now the head of the school and of engineering overall. And with him is Dr. David Kirkwood, who describes himself as interested in all things simulation. David's got a background in software engineering and has worked with simulators of various types for over 15 years. He did his PhD with Clive that was looking at how simulation can be used to test railway track management ideas. And for their presentation, they'll be showing us some of the simulation models used in recent projects that have been done at the university, I think, which Clive, with his colleague Heather, did an introduction to yesterday. So, Clive and David, thank you for being with us here today, and over to you.
Thanks, Carl. So, for those of us who were here yesterday, I'm afraid I'm going to repeat two of the slides I showed yesterday, really just to provide context. And then I'm going to hand over to Dave, who's going to give us some live demos of the simulation capability we have, particularly through what we call the Birmingham Railway Virtual Environment, which is a research simulator that we've been developing over a number of years, that's now moved into being able to collect real-time data, simulation data. You'll see loads of different things as part of the architecture that we've developed. Can you pop us on to the next slide, Dave? So yesterday I talked at moderate length about how we ought to be using simulation synthetic environments throughout the whole life cycle. And as Dave's demonstrating the simulator later, think about this and how this comes together. I was talking about the fact that in projects like HS2, in new green builds projects, or where we're just looking at how we might upgrade, getting business cases together, we want some kind of simulation capability that can do concept development and support business cases, really understanding the sensitivity of the design, where the key parameters are, what we really need to do to get the high level business objectives. Then we go into the system design phase, where we actually want to understand specifically the details, for example, of a ETCS level 2 implementation, or where we might want to think about how we make a robust signaling communications backbone, or whatever it may be. So then we go into a much more detailed approach. Then when we go up the right-hand side of the V, we're into the testing, system integration and validation stages, where at the moment we don't really use simulation. We use simulation in the rail industry in a very ad hoc manner anyway, but on this right-hand side of the V, we're really not very good at using this at all. And using this with hardware in the loop to be able to do virtual testing, what we were calling synthetic environments yesterday, and then keeping that going during the life of the project in what we would call a digital twin, where we're able to bring together real life data from the railway and in parallel be simulating the railway as too. So we can switch between both live, what's happening now, and what might happen in the future through simulation. Now, the key here is that at the moment we have some ad hoc tools that sit in various bits of that life cycle. But really what we want to get to is what I was talking about yesterday, the synthetic environment, whereby we can join all of this up into one seamless golden thread. So if we go on to the next slide, Dave, really what this will then say is that what we might, and what we're working towards and what we have the architecture and the development for is something that is able to stay with the project and become a single source of truth for the project throughout the initiative. So you develop your capability early on in the concept definition. We then augment that model during the system definition. We then further augment it and add interfaces for hardware in the loop in the system realization and test phases. And then we keep it going through the whole life of the project and are able to use that to compare what we thought might happen with reality. And equally, if we want to upgrade the program as we go through its life, we can use the model for that. So we keep that together as the single source of truth, as I say, or as the configuration management tool. And it becomes very clear that we have a virtual asset and we have a real life asset, and the two should interplay together and be as accurate as as possible. Now, in order to do that, we need a good architecture for doing that. We need a good data model for doing that. We need the ability to be able to interchange and bring in and out different simulators and different types of capability. And that brings me quite nicely on to Dave, who's going to show you how that happens.
Yeah, okay, so hello everybody. So I'm just quickly going to run through a few different demonstrations of our Brave simulator, some of which will represent the left-hand side of that V diagram that Clive was showing, and some of which will represent the right-hand side. So just to give you an idea of what we're looking at, I'll just quickly go over what the software is doing. So what we can do in this software is we can draw a network, a railway network, and then simulate it running. So one feature that we can do is we can add scheme plans in the background. So although we've done various different projects and we can import in various different formats, even if we don't have any data, this isn't a particularly good quality example, but if we have some pictures of scheme plans, we can start right from there and we can draw track right over the top of our scheme plans, and then we can edit the properties of the track in these windows down here. We can add a train, we can add a train type, and we can also add signaling and all this sort of thing and the interlocking to the system, and then we can add the timetables, and that is a crash course in how to sort of set up the simulation model. So that gives you a quick overview of the different parts of the system that we're simulating. So we're simulating the network topology, the movement of the trains, and the interlocking. Now, I could go on and build this model, but here's one I made earlier. And this is an example of some of the work that we've done in China. This is Hefei, a fairly large city in China. And the interesting thing about this model and why it fits in with the left-hand side of Clive's diagram is because we actually made this model in 2014. We started to build this model, and the network itself was actually built in 2016. And this line 2, I think similarly, we started work on that approximately 2 years before it was built, and we've actually expanded this model a lot more because now it's gone up to line 7. So China are building a complete metro system for this city. But the interesting thing is our simulation is actually always been ahead of it. So we've had the model before they built their network. And we can see the map in the background there, but if we zoom in, we can see the data that they gave us to work with. And we have the scheme plans, and we've literally drawn over these scheme plans like we did before. And they gave us information about where all the interlocking elements were, and we built this model. And if we just play the simulation, we can see that we have the trains running. And from this, we can take logs of everything that's going on in the simulation. So we can test the timetable, we can work out how many passengers are being moved around by these train movements, and we can also do various disruptions. So for example, I could interfere with a running simulation, and I could tell a train that it has to fail. We can script these sorts of things to happen, and if I fix that train now, and then we can monitor what happens on the network and see and do sort of stability analysis on it and see how robust the timetable is and all this sort of thing. So that's some of the work we've done in China. That's Hefei Metro. And that's the first example I wanted to show you. The second example, a bit closer to home, is we're doing similar work right now for HS2. So again, you probably all realize that the HS2 network isn't running yet. It's still being built. So we're doing similar work on that, where we've taken the scheme plans for HS2, taken all the information about the trains, and we're running the simulation of HS2. Now, the interesting thing about this model is that there are a number of requirements. There's a lot of tunnels on HS2, and the physics of the train is modified as trains go through the tunnel. And there's also some neutral sections where the trains are unpowered. So this was a requirement for this project, that we couldn't just use an existing simulator, or we couldn't necessarily use an existing simulator to do this work, because we had to customize the way the physics work. And because this is our own simulator, it completely belongs to us, and we can change the source code. So that's the reason that we like to use this software, because we've got full control of it. So this is the HS2 model working. Now the software is made as a series of modules, and these modules approximately relate to these tables down here. So for example, we have an interlocking module which is controlling the signals and the routes, and we have a physics module which is controlling the train. We also have a train driver module, and I would normally want to be at the university to show you this, but I've got a quick video that I'm not going to show much of, just very quick example of some of the things that we can do with this modular approach. So at Birmingham, we have our own cab, and we can drive individual trains in the simulation. So this is an example of how we can take one of the modules from within the simulator, take it out and put it as an external system. Similarly here, we have external signaler panel, where so we have man-in-the-loop simulation. So that's most of the stuff I wanted to show you on the left-hand side of the model, but now I'm going to show you some of the work that we're doing on the right-hand side of the V diagram. So what I'm going to show you now is the same sort of thing as before. Now we have this network is made up of a number of scheme plans. It's mostly the West Midlands Trains network. And what you're seeing now is nothing new. There are other systems that do this, but these are the actual trains as they are on the network now. So we're connected up to Network Rail's TD feed, and also their train movements feed. And as the trains move from signal to signal, we can see them moving from signal to signal in this. So it's the same piece of software that we were using for simulation, but now we're using it to show live train movements as they happen on the network right now. Now, the next, so this fits in with the right-hand side of Clive's model, because this network currently exists, and what we're doing now is monitoring it rather than planning, simulating it. What we can also do, which is the sort of things we're currently developing, is we can record these movements. So this is just a table of train movement records that we've recorded. And then what we can do with that, if we can continuously record these movements. It takes rather a large database to do that. But what we can do is, if something were to happen on the network, for example, some unusual event, and we wanted to look back at what happened, I can now play back a previous day's recorded data. So this, it's playing faster than the live data was. But now what we're seeing is, I think this is about 2 weeks ago, it's just some random day that I recorded the day's movements on. And then we can take this to the next level. So these are, what we're seeing now is the TD feed from Network Rail coming from the day that I recorded. But we can then take this to the next level and tie that in with the train movement feed. And we can then put those trains in as simulated trains. So now we're seeing a simulation running. So these trains are running as they were before as simulated trains, but their start positions are taken according to that day. So the idea is, and it's still a work in progress, but the idea would be that we could monitor the trains on the network. If something unusual happens, we can play back that day. We could also play various simulations of a snapshot of that day to see if different decisions could have led to different outcomes. And ultimately, what we would like to be able to do would be to take the live data and switch into simulation as the live data is running, and play forward various what-if scenarios, and that maybe could be used as a sort of signaler decision support tool. So that's everything I wanted to show you today.
Dave, somebody's in the chat asked about linking power. I wondered if you had a live model or a video of the work in Singapore. Have we got time, Carl?
Yeah, we could. You have another minute or two. Yeah, in fact, you're ahead of schedule, Clive. So yes, please do. That's why I was a bit surprised.
I just have to find a suitable.
Yeah.
So I'm not sure whether these Singapore models have the MTS simulator. What we had developed in Birmingham long before I started at Birmingham was a power simulation system, and we've put these two systems together. So
I've got video here I can show.
Oh yeah, if that's okay, Clive. I know I've got an example here, but I've got so many different models.
Let me just request the control. So here we are. Where are we? Right. Okay. Can you see my screen now?
Yes, we can, Clive. Thank you.
Can you still see it? So this is a model of where's this? This is in Guangzhou, and what we've got here is the simulator, as you've seen with Dave talking about, But here what we've got is an additional tab, which is another simulator. So we can link into this other simulators. We have one for multi-train simulators. This is the DC power, but we have an AC power one as well. We also have one for comms coverage for GSMR and also for Wi-Fi for CBTC. And what we're doing here is modeling, let's just go back. We're modeling the substation outputs and the energy flow through the substations, including the losses so this is coping with regen, everything that's going on from this place, a DC power network. We also have a version of this that we can plug a passenger simulation into, so we can show passengers flowing in and out of trains and modeling those through stations. And the key to that is that if we have very crowded trains, what we can do or crowded station, we can show that how that will affect the train service. So fundamentally, the train service will run more. Here's the comms version. So here more efficiently or more appropriately or on time with no passengers as with passengers. So you can start to look at how you manage the passengers in the station. And then finally, at the moment, we're just doing some work on crew development. And the idea of the crew work is to look at how we can schedule and diagram crew over the top of all of that, so that we can put crew diagrams on there and start to look at what happens when crew when trains are delayed and crews cause problems, etc. So there's quite a lot of things that we can extend. So the key benefit of this, and as I was talking about yesterday with this embedded environment, is the architecture, because the architecture allows us to do all sorts of different things, and it's written in such a modular way that you can change things. Thank you.
Thank you, Clive. Thank you, David. That was very interesting again. And would all the other presenters and speakers like to put their cameras back on now and put the microphones on? And I'll start going through a few of the questions we've had. Then I'll try and open it with a bit more of a general discussion and that. There's a few things I'd like to talk about. So if we can start, Sam, I'll start with one of the questions you raised for Peter. And Sam, my colleague, asked, what would the dangers be of using augmented reality in a line-side environment? And do we want to 100% of our eyesight available for hazards? Has this been looked into about the risks using? Is that what you're asking, Sam, or do you want to ask the question yourself? Sorry,
yeah, I can.
Yeah, you pick it up.
Yeah, so I'm not talking about working red zone, for instance, and getting bowled over, but obviously slips, trips and falls is a huge risk that we have out on the infrastructure. Mm-hmm. Getting your fingers trapped in moving PoE, for example, things like that. Has any sort of analysis been performed on the risks, the dangers of potentially using augmented reality and being distracted from the task at hand?
So it's a really good question, and something we're kind of starting to think about, and partly that's why we're trialing this and looking into it, so actually we can begin to actually learn and understand where there could be those sorts of interactions. So yes, you're quite right. In the training environment, it could be quite a sterile environment, but actually when you start thinking of using it out on site, there are different kind of exposures and risks. Yes, it's learning that needs to be done, and something that we would be looking to learn about, and I guess the wider industry as well. So anything that we can learn, we can share. And if anybody has examples or knowledge in that space, I'd be welcome, and be good to listen and learn as well, really, because it's not something HS1 and Network Rail High Speed have done before. So yeah, we are on that early part of the curve to find out more.
So that hasn't been. Thanks very much. Yeah, thank you, Peter. So obviously one that needs to be an ongoing issue if we want to start deploying augmented reality in the field. Very good question. Mike, you've asked a few questions, but I know there's one you've got for Peter on open source. Would you like to ask that one, Mike, for Peter?
Yeah, that first one there, open source. We had, I believe his name's Nicholas, one of the head guys from open source. He gave a presentation at the Nkosi Rig. That was more of a comment. Did you actually use them for your?
Oh, so open space.
Yeah, open space. Yeah, open
Yes,
space.
yes. So yes. So sorry, I think on the slide.
Yeah, I said open source. Sorry, my fault.
Yeah, no, that's fine. I forgot to voice that actually as one of the points. So Jay Newton, who was unfortunately not able to be on the call, the passenger experience one is mostly his area of expertise. But yeah, open space were used, and yeah, it was initially funded by Innovate UK, and then subsequently we've got funding from others, so DFT, some from HS1, and the train operating companies as well. So yes, it is open space who it's been partnered with. Yes.
He does, I think, a 3D model. They simulate people flows, and it's quite an interesting setup.
Yes, exactly that. It was hard to convey everything in the time frame for both models that we're working on. But yeah, exactly that. It maps out, well, not maps out, kind of covers passenger flow and movement in the station, and lets us see how they interact with the environment around them. So yes.
And it might be worth coming in just to say that we've been working with those open space guys and have developed an interface to our simulator, which perhaps answers another one of your questions around open interfaces. So the ability to be able to pick up link simulators is really, really key. We're nowhere near having standardized interfaces, but I think that's somewhere where we should be able to get to, so that what we can do is we can interchange simulators in and out, or join them together to get a systems approach.
No, because I see that so much in defense, and it can easily get locked up in proprietary standards.
Yeah.
And then, yeah, it's difficult to
stuck then. Yeah.
do what we want to do. Yeah.
Thank you, Mike. We're coming back to you because I know you've put a couple of questions in the chat, but I'll move over to Nick. I'll start with a question from myself, Nick, that I thought of when you were saying. First of all, can I say, I think it was a really good way, your analogy of learning to drive a car. Yes, that was my experience as well, and of starting off with my mum and then having to unlearn all the bad habits that she'd learned over the years when I actually got to do my test. Very good. One thing that came to me, I'm sure that's really good with our new staff, but I'll put my neck on the chopping block and say it. Maybe there are certain elements within the industry who are already in who could probably benefit from that as well. Has the college considered offering like one-day courses on that, a few like short courses on things like that?
Yes. So we do continuous professional development. I'll tell you something as well. It's interesting that you say that. I think prior to the COVID lockdown, there were a couple of Network Rail IRC meetings when they were discussing the long-term development plan, and especially how ETCS, etc., could help us with Target 190, etc., etc. And a lot of conversations that I had there as well was, people who've been in the industry, we haven't got our hands around this technology. Some of us haven't seen it yet. We know about it in theory, but we don't know how it operates or how we should design it, etc., etc. So yes, the college should be able to allow for existing engineers as well, or anybody that wants to seek that knowledge, to be able to come into a place, to have a play, have a look and experience these technologies as well. Separately, on another point as well, whilst you got me on the call, we've got all these different simulators. So we saw the simulation or the AR model from HS1. We saw Clive's model as well. We've seen the Adult Common HS2 model as well. I think there needs as well to be a bit more in terms of sharing these models, or trying to think how we can share them, either, like I said, as an educational license, not only, let's say, to the college, but to schools in general and other colleges, and to other colleges where their students might be thinking of entering into engineering as well, because this could spark the interest.
That's a very good point, Nick. I mean, I've just realised, because I know I don't know if we still do it, but I know in the early days when things like Visio and that's first started to come out, you used to be able to get like trial licenses, didn't you, with like a limited number of functions, so you could actually see the tool and play with it before you actually purchased, and also to prepare you for it. Yeah, maybe we do need a similar sort of thing. While you're still on, Nick, as well, my colleague Sam had a couple of questions. Sam, I don't know if you want to ask your two questions for Nick. First one seems to be one of your. At first, I thought the first one was one of your typical cheeky ones, but I can sort of see the point you're getting at. Actually,
keeps putting me on the spot. This isn't fair. So I was interested what your high scores were on Paper Train and on the train station simulator. And more seriously, if you do run those kind of competitively amongst the students, or if they are just a bit of fun at the start of the course.
No. We do utilize them competitively. So, we try to arrange the curriculum. It's not just about here's a game, have a play of it. It's for the students to learn about what are they understanding through the complexities of the game. How does it apply to perhaps maybe an assignment we're setting or the block we're delivering at that time as well. So, for example, we utilize the paper trains game when we're talking about signaling systems, about layouts, so they can see it from that other viewpoint, because it's all well and good me standing up there and saying this is a signal, this is the railway, etc. But unless they get their hands dirty, it can be a bit difficult for them to grasp some of the concepts.
I'd be interested to see a show of hands from those in the audience of who instantly went to the App Store to look up Paper Train to see if they could download it and start playing about with signals and track layouts, because I know I did. I'm also interested
Malcolm's
to know...
already admitting it.
Is it? I'm also interested to know the sort of mix of hands-on and classroom training you have in a typical course at the college, and how the pandemic has impacted that mix over the last year or so, and whether you think perhaps there'd be a year or two of students who've definitely missed out, but do you think that would impact longer term on their ability to perform?
It's been difficult. So I guess one of the things that we've been able to do is we've got quite a modular system of how we might deliver content. So as we've been rolling with the punches in a sense when it came to COVID. So nobody knew how long COVID was going to last. So it's been more of a case of what can we deliver online and which things can we shift to deliver at a time when the learners could come back into the college. So as the learners are now getting back into the college, we're now increasing the practical participation. So just last week, we had our signalling apprentices in the college, and we had a location that was stripped that is connected to our signals and to our track circuits, our axle counters, and they went through that physical exercise of rewiring that location, something that we wouldn't have done during the high point of COVID, should I say. Yeah.
Okay, understood. That's good.
Brilliant. Sorry, Sam. Before Sam's got another question for you, Nick, which I'll let him take in a minute. But and then I'm going to, and you've got one for David next as well, Sam. But what can I just say to everyone? If anyone wants to chip in at any point, please feel free to stick your hands up. Or if you have another question that you'd like to raise, please do just raise your hands or jump in. Please do get involved in the discussion. Sorry. So Sam, you had another one about the balance between.
It's been answered in that very comprehensive answer. I was going to say if the virus had impacted education, were there any plans to add additional work? But yeah, with the way you've changed it around in time, that makes perfect sense. So yeah, it's already been answered. Yeah, and I don't know if Clive, if you want to talk about how the uni was coped through COVID as well, since we've raised that question, it's probably fair to your side as well.
Yeah, well, from our side, we've had. As I suggested earlier, we've been functioning fairly well since March, but there's obviously been a real hit in terms of what we've been able to deliver, albeit the blended approach has really worked well, and things have continued through, but it's certainly had a challenging time, as it's been for everyone, of course.
Absolutely, and I'm sure we're all keen to get back and see everyone face to face, but and hopefully we're on that way now. Sam, you had a question for David about the simulator, about the depot modelling tool as well. Yeah, on the spot again. I was interested, first of all, what you'd coded it up in, because I'm a few years out of the loop on doing such simulations, and I used to live in MATLAB, and that looked like a lovely front end, so I'm just interested what you've coded it in, and I'm also interested in your simulation approach. I mean, given the sort of infinite variability of the perturbation element, I assume it's a Monte Carlo approach?
Yeah, so I wasn't actually responsible for any of the software development side of it. We've got a team of people that take care of that, but I believe it's a combination of C# and Java So not
Okay.
not particularly cutting edge, but adequate for what it's needed to do. And you're right, it runs a Monte Carlo to run the analysis and perturbations.
Do you think you could turn it into a game for Encati?
Funny, we were joking about that offline. I don't know how much of a train enthusiast you'd have to be to want a train depot game.
It's more like what we need for the industry every day. But yeah, good point. Yeah.
But serious side to that question though, the tool itself is actually quite simple. So to play with is quite an easy thing to do. So using to actually experiment and learn from it is quite an easy thing to do. So it wouldn't need to be sort of simplified into a game. It could just be used as a game in its right, if that makes sense.
Cool. All right, thank you, David. I see we've got Francis Capaldi. You've got your hand up. Do you want to? Is there something you'd like to bring in at this point?
Yeah, firstly, thanks to all the presenters today. Some really interesting details thrown up in these past presentations. My question was just more based on, from my view, I'm not typically involved in modelling in my day-to-day work, but a lot of these models that were shown today, I guess, were more based or focused around looking at the design of these systems and perhaps looking at the verification and testing ability that they can help with. Do these models that you've presented today, or perhaps separate models, do you believe that they could help with requirement validation and traceability of those requirements, opposed to using existing tools such as doors? I guess I'll say that's for probably more directed at Clive and the Davids rather than.
Yeah.
Okay, I'll pick that up. So the straightforward answer is yes, and I think what we have in the sector at the moment is breaks in that V diagram process where we move from one approach to another, and we lose that golden thread of doing that. So being able to keep a continuation of simulation as you go through is really important to make sure that we don't design out the fundamental reason for why we did stuff in the first place. So what we're trying to do at the moment is show, through our research, that there is really a space and a benefit for that, and that those the things that we're able to demonstrate at that research level is really key and could later on be used, for example, in the synthetic environment work that others are talking about at the moment.
Okay, thank you, Francis. I wonder if that might lead nicely into there's a couple of I tell you what, I'll if it's okay, Felix, I know you've answered a very good question, but if I can leave that at the end, I'd like to open your question up to everyone on the panel, because I think it's a very good and pertinent one. It was one I was going to ask myself actually, but I might let you do that, Felix. But Malcolm, Malcolm DeBell, I noticed you've got a couple of questions for Clive. I don't know whether they were answered in the chat or if you wanted to raise them about HS2 or
no. Thinking particularly about Euston and HS2, clearly modelling will show whether a particular number of platforms will be able to service a particular number of trains per hour. But at a terminal station, that depends on the flow rate of getting people on and off the trains, cleaning, any recovery time necessary, or and indeed rules such as the train must continue on a particular might be locked into a particular diagram or not. Have you been able to show that 18 trains now will work with 10 platforms, given that's been quite controversial over the last few months?
I guess in terms of the simulations we've done, that's not what we're focusing on, because of just we're really interested in the resilience of the network at the moment. But fundamentally, from a timetabling point of view, it works, and you could use the simulation tools to do that. It's probably worth mentioning that we've also done work some years ago now with Central Japan Railways around, for example, cleaning of trains and all those other factors that affect terminus stations. And I think there is, in a broader answer to your question, there is depending on where you draw the systems boundary, there's things you may well be able to benefit or not benefit from. If you look at, for example, the turnaround that people have at Tokyo Station currently, it's quite then they're not blessed with the number of platforms that HS2 is talking about. But of course, simulation can show you all of those things, and the more you focus in on the fidelity of those particular areas, you can show that.
Thank you, Clive.
Thank you. Thanks, Malcolm. Yeah, Felix. I don't know if are you around there, mate? I was wondering if I could ask you to come up and ask the question you've raised about the benefit of having a live parallel model. That would be quite interesting, I think, to have open for everyone.
Well, I think Clive partly answered it in the chat, but the question was basically a model is fantastic. It's very useful before you actually start doing anything. It's even more useful when you spend time on developing options and then on designing things and checking them against your model. And that's probably about 20% of a project's life. And then you've got another 80% where you need to maintain the problem, as Clive points out. Of course, during that time, when you reconfigure things, then you, of course, use the model to show that the reconfiguration works and that the model works. But it brings us into the big issue of maintaining a piece of software over a period of maybe 30 years, 40 years with all the data up to date, and also maintaining the staff competence to deal with it. The hardware platform is probably almost the smallest element, although because in general they become faster and better, but the software compatibility, and also if you're using lots of different input models in order to make your super model, you need to make sure that those interfaces continue to work. So it's the question was whether the cost of doing that can be justified properly, but I think it's a very difficult question. Sorry, Clive.
Well, so shall I pick it up? So I think the benefits of being able to undertake analysis, if you look at what train operating companies are doing when there's significant disruption, etc. I think there's probably a cost justification there. But actually, the fact that we model and remodel things continuously, and I'm always amazed just how many models, an organisation like Network Rail have of the same different piece of track, because they have one for the power and they have one for the operations and signalling, etc. So I believe that there is a significant case there, and as we move into the world of digital assets, I think we will begin to think of the digital asset as being really a key. How did we ever operate a railway without one? And will be a key part of what almost every new infrastructure project needs to have and maintain and look after. The other issue about this is if you can end up with using your model as the single source of truth of configuration management of what's there, and you do then build into your processes an upgrade of the model as you upgrade the railway, it really does help with that issue that we perhaps have today, where in 4 different places in the organisation we have a slightly different view of what's there, how something's wired, etc., and it can be kept in the model.
Okay, that's thank you very much, Clive. That's very good. I think I'll tack something onto that and something to think about, which I don't know if anyone else has, but there'll be an ongoing question. I mean, the problem we're always having, certainly with the deployment of new technology, is trialing it on site and so forth, and how much, I would say, how can we afford not to use modelling and simulation actually in the future, because we can't, we're getting increasingly pushed for access time, and we will need some other method of running tests and so forth, rather than relying on so many field tests, I would have thought. I don't know if anyone thinks that the models will get to that point of being able to be used as a replacement for that, but I think we need to be aiming for that, certainly, if we're not already there, which I think we really are pretty much, aren't we? I think. But we need to then of course we have a culture change that we've got to overcome, of getting people who are going to do the final sign off to be comfortable with using these models for that purpose, and I think that's the next big challenge. Okay, had a couple of anonymous questions. One saying that it's an incredibly powerful tool, Clive, and you obviously want to keep it proprietary. But are the interfaces documented anywhere that third parties could perhaps add their own modules without revealing the inner workings, or is that something that you're not looking at the moment?
So it's not really something that. So the idea of having open interfaces was raised in an EU project that we worked on with Network Rail and many others, and the idea of being able to do that was sort of an integral part of that project. But they've never moved on to a standardised approach. But as you can probably tell from me advocating, I think that would be a really good place to be. In terms of where we are in this space, I think we're all about proving that this is possible and you can do it, so that then others can take that forward and implement it appropriately. But certainly we must get ourselves, and at the moment we're still struggling in the industry to have a data model. So then thinking about interfaces between simulators is quite a big deal. But fundamentally, I think that's where there would be huge benefit to get to, because then you can use this in, sometimes you want a detailed microscopic simulator, but sometimes a spreadsheet is good enough, and you can use those interfaces as you see fit.
Yeah. Thank you, Clive. Someone also asked on a side note of that, are things like signaling principles hard coded into the model, or can you could you change it to look at using different signaling principles, or is that more of a?
Yeah, so you can write it in a variety of, in terms of how any simulator you can change. We, for example, have a module for virtual coupling, so a signaling system that doesn't exist yet. So there's potential to do that in a model sense, in a modular sense.
Yeah. Okay. All right. Thank you, Clive. Can I just say thanks, Richard? I was going to ask that person before what just to confirm their name, so I don't know that's Karen. Karen, it's all right. I will get your question. It's a very good one. I will come back to it in a minute. But similar as this topic, Stephen Bull, I noticed you've just raised something. I don't know if you want to bring it into the chat, because you raised a good point there about what I mentioned about using models for assurance.
Yeah, thanks. Just thinking that you mentioned the culture change for using models for testing, and I think that's a very important point. Obviously, that's only going to be acceptable to people when they're confident that those models are a sufficiently faithful representation, so that you can trust the test results. I wondered what thoughts had been. I mean, I guess this is an early stage for that, but I wonder whether anyone had given thoughts to how they do that.
Shall I say something quick? But I think one challenge is validating a model for one application doesn't necessarily mean it's valid for another application. So there are challenges around that, but you can certainly get confidence from real world data in what you're doing and validate in particular areas. But I think there is a slight danger in some of this space where we assume that because something's right for one particular application area, the model can then be used for all sorts of things that it wasn't designed for. So in a rollout sense, that needs thinking about more carefully. But there are some practical ways around that, albeit they may well constrain things.
Okay, thank you, Clive. If I could now, I think that there's someone who has a very good question. Sorry, is it that someone whose name, the name of the chat is FEINY? Is that but Richard referred to them as Karen? Is that right? Karen, are you on the call? Sorry. Yes. She's asked the question's been asked. And it may be more for Clive and Nick. You'll certainly have a view of this, but maybe we should. I think it would be fair if anyone else can answer. Is how, and it's the question of how do we encourage more women to enter the industry, which is a good question topic at the moment. And as Richard has said in the chat, we need to be. I think this is not only an issue with the railways, I would say, but certainly with engineering in general, which is one I've got to be honest. I've always struggled to understand why this. I mean, when I did my degree, I was one of. There was literally in a class of 80. There was literally 3. Ladies on the course, which seemed very bizarre to me at the time. It's a very skewed thing. Why engineering is never and railways have never appealed to.
I'm here, by the way.
Oh, hello, Karen. Can you?
Hi.
Would you like to answer?
Hi.
Sorry, raise your question yourself. Is it Karen? Sorry, by the way. I know it's David.
It is. Yes.
Yeah.
Yeah.
Oh, sorry.
Yeah, so embedded in my own work around innovation, and I work across sectors. A few days ago, I asked the question about youth groups and across sectors. If you remember, Carl, that was me.
Yes.
You know, yeah. And so I've been involved with STEM or STEAM education, both at the local level and the global level. And so even with all due respect to your incredible intelligence, gentlemen, when you see you all, it's stark, you know, what's missing in this picture. And so I think there are different ways to address it besides education, even media. If you see billboards around town and you see women in rail, you know, there could be some really interesting partnerships that you do with universities, like the marketing or film or, you know, people that are in social media, etc. So it's partnering with media so you create visible representation of women in rail, both at the, you know, at the adult level, but then again, you cannot be what you cannot see. So of course you have to address it early on in the pipeline from little ones, you know, so they can aspire to something that they didn't think of, and offer new ideas perhaps as well. So that's my 2 cents.
Okay. Yeah, we we did have a number of speakers earlier in the week. I mean, I must confess that today's the panel isn't reflecting that, I know. But have we got any comments on any initiatives that we're talking about? Anything that anyone would like to share? Sorry, just while we're on the subject, since it's a fair subject to ask about. Certainly, Clive.
So just to say, I think there are signs of improvement in this area, and interestingly, we're talking about simulation and analysis in this space today. I think it's actually one of the areas where I do see a lot more diversity in the sector, and certainly if you look at the lead people in Network Rail and HS2 in this space, they are female members of staff. I think in terms of just numbers, just some factual numbers, we're up in engineering now at about 18% of our intake as being female. That is not great, but it's better than when I was an undergraduate and when Carl was an undergraduate, as he says. But there's an awful lot more to be done. In the rail industry, I believe, I obviously look at other sectors, being head of engineering here, is doing a lot in this space through women in engineering, the young railway professionals. There's some really good initiatives in the rail sector to do this. Of course, there's always more work to be done. Yeah, there is stuff happening, but it's something that a number of us are involved in and really keen to make happen. And I know in Catty at the college, similar. The gender balance is challenging, but there's lots of initiatives to try and support those activities.
Again, follow on to that from what Clive was saying, again, prior to COVID, like I was saying, we had a lot of engagement with schools, different schools and colleges, you know, talking to everybody about potentially the benefits of rail and the benefit of having a career in the railway, and also as well opening up to the college to the local community as well. Also, you know, brought in a diverse complement of people into the college as well for them to see what the technology were. Again, we're not doing enough. I know that for sure. I think though as well, sometimes, you know, the problem, or if we look at this as a problem, that it can actually start from within the home as well. So peer pressure and what expectations or traditional roles that females should have in terms of careers as well. So it's an across the board thing that we've got to address as well, not just, I guess, in education, also in the home, and also, as Karen said as well, in the media and the publication and what we put out there.
Yeah. I would like to say that we have got an EDI charter within RIA, which we are taking very seriously. We're also actively supporting the Women in Rail initiative and trying to organise a joint event with them as well. We have had RIA technical events where over 50% of our presenters have been female, and we usually get on average about 25% of female delegates to our events. So that's a good sign as well. But like we say, there can always be more to be done, certainly. And I think Malcolm's also just raised a point there. and we think like we all said, we've got to start at primary level and start as young as possible. This is and I think there is a certain amount of I always personally found it very surprising that it was, but there's obviously still something that's naturally happening to still cause this. So, but we are trying our best to try and improve, and we will encourage more and more female speakers, certainly. Sorry, so have we got any more questions?
Oh, sorry, just really briefly, quick follow-up. I love the idea of addressing home. When you're talking about unlocking innovation in whole systems,
yes,
you're thinking about family education. So I love that idea of, so that was a great idea.
I'm glad you say that, Karen, because as someone who home educates their children, I'm hoping to encourage STEM from a very early age. So let's hope so. That have been this area with APTA, Mike. No, that's a good question. We probably need to we should have a chat in Corsi, and APTA should probably have a chat about if we can do something on this. So for those who don't know, APTA is the American equivalent of RIA, who we're working quite closely with us, particularly through in Corsi. And maybe we should have a look to see if there's anything we can do as a Karen, to see if there's any sort of joint initiative we can discuss as well. I think
we can bring that up next week also, Carl, at the next meeting.
I think that, yeah, good point. We have the next in Corsi TP meeting next week with APTA. So yeah, I think it's one to bring up maybe, and that's something that we could definitely do as an initiative, Mike. Yeah, that's good. And we have a lot of good people who could be used to promote that, certainly within the UK side, and I know there are on the American side. So yeah, let's raise it next week. It's a good one. Mike, did you raise another question, did I say? Or does anyone else have another question that they'd like to ask the panel? Any questions? Gosh, we seem to be bashing through it this week. Today, sorry. Is there anyone? Anything? No. Well, it looks like we're.
Well, one thing, I did have one thing real quick.
Yes, Mike.
I've been doing a lot of things on benefits analysis and understanding benefits. Like when you're doing network rail projects, things should link up to the control period goals, right, and strategies. So those benefits, in many cases, aren't quantified and to define my threshold and objective requirements. So. And you can define scenarios and use cases to be able to maybe test that out or determine what these things are and use that as part of your validation. But has that been done? Has that been a driver, let's say, for using more simulation to break out this connection between business case and picking systems that actually could deliver that or have the potential of delivering that?
Certainly that's what's driving. So I sort of play ride two horses at the same time. One is rail engineering and the other is systems engineering for INCOSI and those activities. And very much, you saw I showed a V model, but very much being able to link the simulation more directly into the systems engineering process to ensure that when we set off with a high level mission and a business case that says we need to have so many trains per hour or whatever it may be, that we actually understand during the design as we go into the physical implementation of the design of the system, that we don't design out those key aspects that in a closely coupled system like rail, there is a danger of doing it. And I think I've certainly observed that in the UK as happening, where we set off with a high level business case in a particular area, but as it comes down into the actual instantiation of the engineering system, we've forgotten that. And some of that's because of that jump from one simulation mode to another, and that continuation of thread, I think, is really important and should de-risk innovation and investment in this area, because we should be more certain that we're going to get the benefits out the other end that we're expecting, where people don't believe business cases, where hopefully the simulation capability can really support that activity.
Yes.
Yeah.
And I was going to ask the question, Clive, I must confess, at the very start about where to see who would bite or where we should start using modelling and simulation. But I think we've all agreed right from the get-go and all through the entire life cycle, as several of you have mentioned. And it needs to be a part of pre-feasibility, feasibility, optioneering, development, and also approval. And that's a big shift for the industry, I think, and but it's one that we need to go through, and let's hope we can get it there sooner rather than later. I mean, like you said, I mean, we need to keep pushing for both the sector deal and TR 190 to push for this sort of technology, I would say, and it's the only way we'll make the savings we need to make. Okay, well, has anyone got any other questions that they'd like to ask while they're on? Anything from the panel? Any final thoughts?
I've just got a little bit of thought as well when we was talking, I think, from Felix's first question about benefits, cost benefits, and of such with simulations. And I think one of the things as well, apart from the systems integration point of view of how we can use simulators as well, we must never forget as well that, you know, simulation allows us to keep people off the rails. And therefore, you know, what is the value of a life? Yeah. If we can keep people off the rails and get them using these simulated systems, you know, saving lives does count. Absolutely.
Well said, Nick. Yeah, definitely. Yeah. Thank you very well. On that, I'll. Someone just put a very good point to me that flight simulators have been used to train pilots for years for that very reason. So yeah, we should be thinking in that mentality, shouldn't we? Really, that's a very maybe that could be our slogan or tagline. Flight simulator. When we next time someone says, "How do we know we could use this to test safety critical systems?" Or we could say, "Flight simulators have been used to train pilots for years." So there we go.
And shipboard simulators, being a Navy guy myself, that's huge.
Absolutely, good point, Mike. Oh, Malcolm, would you like to come in quickly?
Yeah, just going to make the point that flight simulators are a jolly good example of where a simulation has to be kept current and the correct fidelity throughout the life cycle of the product.
Very good point, Malcolm. Yes, and
same with train simulators as well, driver training.
And I don't mean to be funny. I don't think, as far as I'm aware, the airline industry hasn't got into the trap of the idea that everything should have a 30-year life like we have. So I imagine it's got to be kept up. They've got to be kept fairly updated, fairly regularly. I've not worked in the aviation industry there, I'm afraid, so I couldn't comment. But I would have thought that if they can keep that up, then we should be. Then it certainly makes a case for what we should be doing. Thank you, Malcolm. That's a very good point.
Can I just comment on that very quickly? The jumbo jets which are now going out of service are 30 years old.
All right.
So it is the same problem, and there's continuous updates on technologies on those planes. So I think working with those people rather than thinking that we are all different is probably a better idea.
That was the point I was trying to make. Sorry, Felix, but you've done it much more clearly than I have. Thank you very much. That's a very good point. Because I mean, I think although the vehicle may have one thing, I think someone mentioned it in yesterday's presentations that although the vehicle may have a life of 30 years old, the technology on it generally probably won't. There will be changes that need to be made much more regularly than that. And certainly, like you say, that's a good point, Felix. The aviation industry have been already doing it, and there's something we can learn from, and that's something that we need to be looking at. I want to thank you all. On that note, I think, can I just thank all the presenters and give them all a very big virtual round of applause for another excellent group of presentations, some excellent demonstrations. I'm quite happy to keep the call open for another half hour for anyone who wants to do some networking. And Dave O'Neill, if you'd like to show some of the simulator, you're more than welcome. Your depot model, you're more than welcome to. If you've got it handy and would like to load something up for the last half hour, if people would like to see that, I'm quite happy to do that. We can even have some chat in the background while you're getting set up. If you'd like to, let me know. Just to let everyone know, tomorrow obviously is the final day of this event on tomorrow afternoon, and tomorrow we're going to look at some of the challenges to the industry of implementing systems engineering and some of the challenges that the industry is facing where we will need systems engineering to move forward. We're going to have a presentation from Arvinder Sangha, who you may have seen earlier in the week, from Harmonics, who's going to be talking about some of the challenges of getting new technology into the industry. Also, David Shipman from Network Rail is going to be talking about some of the challenges they're facing from their side, particularly in terms of how to automate design and testing. And we're also going to have then two presentations looking at big new projects and the challenges they're facing. First from NASA Miorthi at High Speed 2, and secondly from Richard Jones from the Black Country Innovative Manufacturing Organisation, who's going to talk about light rail vehicles and how they could be used to supplement our transport networks in the cities. So and local area transport. So thank you very much again, and please do come. You're welcome to stay until 4:30. David, like I said, if you'd like to show some of the simulator, some of the model, please feel free. And if anyone's got any questions or wants to talk, please feel free to put your camera and microphone on and speak up. And whoever wants to stay on is more than welcome. We got some interest. Not anything. Got anyone? Hi, Sam. All right, Matt. Oh, hi, Amanda.
How are you?
Not so bad, mate. Yourself?
Not too bad. I did have a very quick question for David. Apologies, I was trying to raise a question. It was on the depot modelling capability. Do we consider items like future service requirements in terms of potential upgrades to depots, or do we consider the pictures in now?
It can be a hypothetical scenario. A lot of the opportunities we look at are hypothetical scenarios where they might have a timetable, for example, that's slightly indicative of what they're set to look at in a couple of years' time. We've just finished a piece of work with one of the TOCs where they are in the procurement stages of rolling stock. They know that the service patterns are going to change when the new rolling stock comes in, but they need to understand what the depot is going to look like for that new rolling stock. So we, a bit of toing and froing to work out what that timetable is going to look at based on their anticipated service provision, and then created a hypothetical scenario for the model to simulate, and gave them an understanding of what modifications they needed to make to the depot based on entirely hypothetical situations. What's interesting in that situation is that we've talked about how we use the tool to validate and verify design and various other things. At that stage, it's really important to recognize that it is a model, and there are limits within that model that prevent it from being absolutely real to life. And one of the biggest constraints within depot modeling as a whole is that there is a huge people element to the decision making on a depot during the course of the height of it, which is normally at night, where decisions are made in reaction to situations that are happening, which the depot model simply cannot do. But if we can take a hypothetical situation of service patterns that might be rather than the current, and take an educated make an educated assumption on what the regime for that night is going to look like.
Okay, but would that on that note, would that not potentially feed into processes? Like you say, it's a people thing, but ultimately, and it is an ideal scenario, there should be processes there to handle these scenarios. Is there a feedback loop, or
yes. So the output of the model can be used to inform those processes, or to optimize those processes. What I mean by the reactive decision making is, having worked on depots, I've seen the regular occurrence of trains turning up at a depot and it's not the right train, or the train comes in the wrong formation or the wrong way round, and decisions have to be made around that sort of thing. And obviously you can't simulate reaction in that way because it's a live environment. But if we were using it as a planning tool, we could use it to anticipate or use them as, model those perturbations to understand how the depot could cope.
But I suppose there's also simulation, and I think testing is very limited as well in terms of the failure scenarios. We focus very much on happy day scenarios, and there's a lack of failure and performance testing. Is there anything that can be done from a modelling perspective?
What, to failure and performance of the depot, of the rolling stock?
Yeah, to explore more scenarios where not just the normal scenarios, I suppose, more failure scenarios. Can a depot potentially cope, or combination?
Yeah. So the question was asked, you know, can the resilience of the depot be tested against perturbations? And yes, it can very easily. We can chuck into the simulation as many curveballs as you like, really, and to quite a specific level of detail as well to stress the depot. And through the piece of work I described earlier, we did that. We went through various iterations of just tweaking the model in different ways. What if this happened? What if that happened? What if the wheel lathe broke? What if we can't do as many carriage washes as we want to? What if this set of points is not working? Or what if that train has got it takes longer to find a failure on that train, or that maintenance finds 3 hours worth of work arising? The versatility of it is quite broad.
Okay, that's useful to hear. In terms of validity of the model, I suppose, has there been a full loop in terms of confirming how accurate the model is, or is this a continual activity?
It's kind of a continual activity. The word faithfulness, I think, was coined earlier regarding simulations, and we have seen scenarios where the depot manager has been sat watching exact replications or exact simulations of problems he's used to seeing back at his depot on our simulation without having told us what they are. You know, we normally have a hiccup around about 1 o'clock in the morning. Oh, look, there's a hiccup at 1 o'clock in the morning, or we can't get said train out because of this. And lo and behold, so the confidence is built through that learning of the tool's abilities. I think one of the telling signs of the accuracy, and I hope I'm not being too unfair, sometimes we give clients answers they don't expect or don't particularly like, because they have a predetermined answer in their head and it's not quite what it is, but it's more real to life. And I suppose in every situation like this, it's only as good as the data you put into it, and it's only as accurate as the assumptions you make. The fewer assumptions, the more accurate it's going to be. But sometimes when you're modeling a hypothetical scenario, you've got to make a lot more assumptions, and therefore you've got to be aware of that sort of margin of error that can occur.
Yeah. Okay, that's great.
Brilliant.
Of the remaining on the call, Carl, is it worth just having a show of hands who wants to sort of have a run through of the tool itself? Or
would anyone like to see the tool? If you would just raise your hands. Have you got any interest?
What I was actually going
we've got
to
Nick's very interested. I thought Nick might be interested.
What I was going to do is, if it's a couple of you, what I can do is set up a separate Teams call at another date. I'm just conscious of how late in the evening it's getting.
That's true.
So if I drop my email address into the chat, do you want to email me anyone who's interested in a demonstration, and we can set something up over Teams at a later date? Is that okay?
Yeah,
that's probably better for you as well, actually, Dave, wouldn't it? We'll have a more in-depth discussion rather than rushing it. Yeah, good idea.
Yeah. So there we go. So my email address is there. Feel free to give me drop me a line, and we can arrange something.
Thank you, David. That's excellent. Well, on that, I think I'll close the call now. Thank you all again. Thanks, David. Thanks, Nick, and thanks, Arvinda. And thank you all. And Arvinda, we'll see you tomorrow. Look forward to your presentation tomorrow. It's you again, isn't it? Paul's given this one to you again, hasn't he, mate?
I was about to have drawn the short straw, but that's definitely not the case. But yeah, it'll be a pleasure to speak to you all again tomorrow.
Looking forward to it. Thank you, Arvinda. Yeah, it was a pleasure to have you again. Thank you very much, everyone. Everyone have a good night. Stay safe. Take care.
Thank you.
See you guys later.
Thank you. Bye.
Bye.
Bye. Bye.